Suppose alpha plus beta minus gamma equals to pi radians. We need to show that sine squared alpha plus sine squared beta minus sine squared gamma, that equals to 2 times the product of sine alpha, sine beta and cosine gamma. Okay, let us begin. So here we're going to start our proof from the left hand side, where we have sine squared alpha added to sine squared beta minus sine squared gamma. Now we are going to use an identity. We know that sine squared theta added to cosine squared theta, that's equals to 1. So what we'll do, we can express sine squared theta as 1 minus cosine squared theta. So using this, we are going to change the first term and the third term. So sine squared alpha is going to become 1 minus cosine squared alpha. We are going to keep the sine squared beta intact. So we have sine squared beta minus sine squared gamma. So that is 1 minus cosine squared gamma. So we should get negative 1 added to cosine squared gamma. So here 1 and 1 gets cancelled out. Now we are left with there. So this, let's cancel it out. Negative cosine squared alpha plus sine squared beta. So if we take negative as the common factor, so we will get cosine squared alpha minus sine squared beta. Then we have added to it is cosine squared gamma. Now the whole reason we use this transformation, because we wanted to get cosine squared alpha minus sine squared beta. There is a standard formula for this. So cosine squared alpha minus sine squared beta, this is actually the product of cosine of the sum of the angles multiplied to cosine of the difference of the angles. So now what we get here is, so let's rewrite the second term as the first term. So we have cosine squared gamma minus, so cosine squared alpha minus sine squared beta, that's going to give us cosine of the sum of the angles alpha plus beta multiplied to cosine of the difference of the angles, that means alpha minus beta. Okay, now what we'll do, we're going to change cosine of alpha plus beta. Since we know that alpha plus beta minus gamma equals to pi radians, so here alpha plus beta can be also expressed as pi plus gamma. Now let's take the cosine function on both sides. So we get cosine of alpha plus beta, this is going to be equals to cosine of pi plus gamma, meaning cosine of alpha plus beta, that's going to be equals to, so what is cosine of pi plus gamma? That's simply going to be cosine gamma, but we'll also have to take care of the sine. So pi plus some angle theta means we are in the third quadrant. Now in the third quadrant, only the tangent function is positive. We have OASTZ. So in the third quadrant, the tangent function is positive, everything else is negative. Since we are working with the cosine function, so it should give us a negative value. In other words, we're saying that cosine of alpha plus beta, this is the same as negative cosine of gamma, provided we have the condition that alpha plus beta minus gamma equals to pi radians. So now what we get here is cosine squared gamma. So cosine of alpha plus beta, when we replace with cosine gamma, we are going to get positive cosine of gamma multiplied to cosine of alpha minus beta. Now we're going to take cosine of gamma as the common factor. So cosine of gamma gets multiplied to cosine of gamma added to cosine of alpha minus beta. As we can see here, we needed cosine of gamma, so we have taken out a factor cosine of gamma. Now what we'll do, we're going to add these to cosine function, but before adding, let's do one thing. Let's change cosine gamma back to cosine of alpha plus beta. So that means we are going to get cosine of gamma multiplied to negative cosine of alpha plus beta added to cosine of alpha minus beta. In other words, what we have here is cosine of gamma multiplied to cosine of alpha minus beta minus cosine of alpha plus beta. So here what we have is the difference of two cosine function. So if we use the fact, that means if we have cosine of c minus cosine of some angle d, this can be also expressed as 2 times sine of the angle d plus c over 2 multiplied to sine of the angle d minus c over 2. Okay, so now what we get here is cosine of gamma multiplied to 2 times. So we will suppose that alpha minus beta, that's equivalent to C, and alpha plus beta, that's equivalent to D. So we have sine of the angle D added to C. So D added to C, that's going to give us 2 alpha divided by 2, multiplied to sine of D minus C, that's going to give us 2 beta over 2. So here we can immediately factor out the factor 2 and rewrite the expression to get 2 times sine alpha times sine beta multiplied to cosine gamma, and this is exactly the expression on the right hand side. So let's re-verify. So we needed to show that it was the given expression on the left hand side equals 2 sine alpha sine beta times cosine gamma. That's what we have got. So we can say that thus the left hand side of our given trigonometric identity, that's equals to the right hand side, hence proved.